Hello everyone, in this video I'm going to discuss the example for continuous random variable. Kindly refers to the question, the probability density function of a continuous random variable x is given by the situation given. Kindly illustrate the situation in a real number line because it's a probability density function. So by referring to the situation here we have the negative 1 until the 2. So the function will be kx squared. Next from 2 until 4, the function will be k. Other than that, we have 0. So question said k is a positive constant. Show that k is equal to 1 over 5. So let's begin. Summation will be equals to 1. So integrate start from negative 1 until the 2. So where we have k x squared dx. Plus integrate start from 2 until 4. Function k dx which is equals to 1. Kindly integrate the situation. So x to the power of 3, bracket, here we have k over the 3, then 2 negative 1. Plus, we have the k, bracket, we have the x, 4, 2, which is equals to 1. Kindly substitute the situation, k over the 3, bracket, then 2 to the power of 3, we have 8, minus, we have negative 1 to the power of 3, we will have negative 1. Plus, we have the k, bracket, 4 minus the 2, which is equals to 1. So continue. So in here we have k multiplied with the 9 over the 3. Then continue. Plus we have the k multiplied with the 2 which is equals to 1. So simplify the situation. We have 9 over 3 which is equals to 3k plus with the 2k. So we have 5k which is equals to 1k which is equals to 1 over 5. So we already shown the situation. Next, calculate the probability. From here we have probability that x which is greater than equals to 1 less than equals to 3. So based on the number line, we have to integrate start from 1 until 2. For the function, we have x squared over the 5 dx. Plus integrate from 2 until 3. We have the function k which is equals to 1 over 5 dx. So kindly integrate the situation. We have x to the power of 3, bracket, 1 over the 15. So here we have 2 and 1. Plus, we have 1 over 5, bracket, we have x, 3 and 2. Kindly substitute the situation. 1 over 15, bracket, we have 8 minus the 1. Plus, we have the situation. 1 over 5, bracket, we have 3 minus the 2. So in here, we have 7 over 15, plus we have 1 over 5. Multiply the situation with the 3. Then we will have the situation. 7 plus with the 3. Then we have 10 over the 15. If we simplify the situation, probability that x is greater equals to 1 and less than equals to 3, then we have 2 over the 3. Next, continue. We have the probability that x greater than 0. So here we will have the 0. So my suggestion would be, making use of the situation, we have 1 minus integrate start from negative 1 until the 0. For the function, we have x squared over the 5 respect to x. Then we can find the probability x greater than 0. So in here, 1 minus, we have x to the power of 3, bracket, 1 over the 15, bracket, we have 0 and negative 1. So if we substitute 0, and we will have 0, minus, if we substitute 1, and we will have negative 1. So from here, we will have 1 minus 1 over the 15. So the probability x greater than 0, where we will have 14 over the 15. Next is to find the median. So as we all know, Fm which is equals to 0.5. So before we begin, let's test the situation. Integrate start from 1 until 2. For the function, x squared over the 5 respect to x. So if we integrate the situation, we have x to the power of 3, bracket, 1 over the 15, 2 negative 1. 1 over 15. So we will have 8 minus bracket negative 1. Then we will have 9 over the 15. So in here, we have 0.6. And then notice that it is greater than 0.5. So we are sure and confirm that m is located in this part. So rewrite the situation. Integrate negative 1 until m. So the function will be x squared over the 5 respect to x equals to 1 over 2. So it refers to the previous situation. So we have x to the power of 3 bracket. here we have 1 over 15, then m and negative 1 equals to 1 over 2. If we substitute the situation, so we will have m cubed minus the situation negative 1 equals to, we have 15 over the 2. Rewrite the situation. So in here, we have m cubed, which is equals to 15 over 2 minus the 1. So in here, we have 13 over the 2. So m cubed. Based on the situation, m will be equals to the cube root of 13 over the 2. So by referring to the calculator, and we have 1.866. So that is the value for m. Next, refers to the situation. Here we have the negative 1, here we have the 1, and then here we have the 2, 3, and 4. Substituting the negative 1 into the situation, and we will have negative 1 squared, where we have 1 over 5. So let's say here we have 1 over 5, where we have 0.2. Continue. If we substitute 0, then we will have 0 over 5. If we substitute 1, again, we will have 1 over 5. If we substitute 2, then we will have 4 over 5. So if we substitute 2, then we will have 4 over 5, which means that 0.8. So 0.2, 0.4, 0.6, 0.8. So the situation is around here. So the graph, x squared over 5, where we have the quadratic. So that is the situation. Y, where we have x squared over the 5. Next, continue. If we substitute 2, and then we will have 1 over 5. So here will be the location. Continue until 4. So here we have the straight line, where y is equals to 1 over the 5. So that is the graph for the function fx, or the small letter f. Next is to find the mode. Refers to the graph, find the highest probability. So notice that here will be the highest probability. So the mode, where we have x, which is equals to 2. Next is to find the mean. As we all know, the ex, where we have the formula, integrate negative infinity until infinity for the function f multiplied with the fx dx. So let's begin. Ex, where we have integrate, start from negative 1 until 2 for the function x to the power of 3 over the 5 respect to x. Plus, start from 2 until 4. So here we'll have x over the 5 respect to x. Kindly integrate the situation, x to the power of 4, bracket, we have 1 over 20, 2 negative 1. Plus, we have x squared, bracket, 1 over the 10, we have 4 and 2. So let's substitute the situation. So if we substitute the 2, then we will have 16. Minus, if we substitute negative 1, then we will have 1. So from here, we have 15 over the 20. Plus 1 over the 10. If we substitute the 4, then we will have 16. If we substitute the 2, then we will have a 4. Plus we have the 12 over the 10. So if we simplify the situation, then we will have 39 over the 20. So that would be the ex, expected value, or we can say the mean. Next is to find the ex squared. So the formula would be integrate negative infinity until infinity. So here we have the x squared multiplied with the fx dx. Referring to the situation, integrate, we have negative 1 until the 2. The function will be x to the power 4 over the 5 dx. Plus integrate 2 until the 4, we have the x squared over the 5 respect to x. Kindly integrate the situation. So x to the power 5, bracket, we have 1 over 25, 2 and negative 1, plus we have x to the power of 3, bracket, 1 over the 15, bracket, we have 4 and 2. 1 over 25. If we substitute the situation, then we will have 32 minus 1. Plus, we have 1 over the 15. If we substitute the 4, then we have 64 minus the 8. Then here we will have 33 over the 25. Plus 56 over the 15. If we simplify the situation, then we will have 379 over the 75. So next is to find the variance. So in here we have the variance, where we have 379 over the 75 minus the ex, where we have 39 over the 20, bracket the square. 1501 over 1200 or 1.2508. So that will be the variance. Continue. Variance bracket 2 minus 3x. So based on the properties, we have variance 2 plus we have variance negative 3x. So in here we will have 0 and then we have 9 multiplied by the variance x. So 9 multiplied with 1501 over 1200, have 4503 over 400, or we can say 11.2575. So that is the variance 2 minus 3x. Next is to find the cumulative distribution function. So we have 4 parts, A, B, C, and D. So let's begin with the A. So notice that we have the domain where we have t less than negative 1. So the function will be integrate, start from negative infinity. The function will be until t, 0 dx. So we have ft, which is equals to 0. Next, focus on part B. So t is greater equals to negative 1 and less than 2. So integrate, start from negative infinity until the negative 1, function 0 dx, and then plus integrate, start from negative 1 until the t for the function x squared over the 5 dx. So based on the situation, here we will have this part. If we substitute negative 1, and we will have 0. Continue. Integrate this part and we will have x to the power of 3 over the 15 bracket. Then we will have t negative 1. So if we substitute the situation, so we will have t to the power of 3 minus bracket, we have negative 1. So as a conclusion, the ft will be equals to 1 over the 15 bracket t to the power of 3 plus with the 1. Next, continue part C. So here we will have t greater equals to 2 and less than 4. So the function will be f2 plus integrate, start from 2 until the t. Function will be 1 over 5 dx. So as we can see in here, if we substitute 2, means that we substitute into this part 2. So if it's a 2, then automatically the answer will be, here we will have 9 over the 15. So continue. So we have 9 over the 15 plus bracket, we have x bracket 1 over the 5 bracket, here we have t and the 2. Kindly substitute the situation. We have 9 over the 15 plus with 1 over 5 bracket, we have t minus the 2. So kindly simplify the situation. So here we will have t over the 5, continue, plus 9 over the 15 minus 2 over the 5. So in here we can say that the ft, which is equals to t over the 5 plus with 1 over the 5. Finally, the part D. The domain will be t greater equals to 4. So here we have f4 plus integrate, start from 4 until the t, function 0 dt. So again, if we substitute 4 into this part and we notice that we will have 1. So the ft will be equals to 1. As a conclusion, the ft will be equals to, start from the 0, then continue, we have x to the power of 3 plus with the 1 over the 15, then continue, we have x plus with the 1 over the 5, and then finally we have the 1. So that will be the CDF. So regarding the domain, refers to the situation. So number 1, we have x less than negative 1, x greater equals to negative 1 and less than 2. Then x greater equals to 2 and then less than 4. Finally, x greater equals to 4. So that will be the cumulative distribution function. So here we will have fx